Good morning, dear friends and students. It gives me immense pleasure to be here again for my favorite course, Flight Mechanics. This course belongs to the 4th semester of Aeronautical Engineering from Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad, India. I am in the process of Module 4, which is Maneuvering Flight, and in my last lecture I have covered about turning flight. In that we have seen the acceleration, how the acceleration will vary, centripetal force, load factors, and some equations. Before that I have done the climb performance in Module 3. In climb we have seen the climb angle, maximum rate of climb, range for the climb, descent, maximum velocity, minimum velocity, stall velocity, velocity for the maximum range, velocity for the maximum endurance. These are things I have covered in my previous classes. Today I am going to take some topics related to the problems solving on aircraft turn rates, and this will see some problems here. So here I will see that here we have the turn rates, angular velocity, then problem 1, problem 2, problem 3. So introduction to turn flight. So turn flight, we have discussed that here it is an accelerated flight. Accelerated flight, and if you see that this is your turn. So at every time you have the velocity, and this velocity there is a radius and there is a force Fc. This is the acceleration AR, and there will be a Fc. This force will be acting when you are rotating like this. This will happen once you are having some bank angle. So if you see here, this is your bank angle phi, and here if you see the weight is here, lift is here, this will be L cos phi. This is the lift. So here if you see, some forces will act in this direction also, and that we have find out the load factor N is equal to L by W and 1 by cos phi. This we have seen, and we have also find out the radius of this. This is the radius. So this is also depend upon the phi and some other velocities. So this we have covered in our previous lectures. So I will discuss about the now turn rate. That time for a complete turn is equal to time for a circle. We know that 2 pi r by velocity of the aircraft. Just now I have shown you. The angular value of a complete circle is 2 pi radian. Hence the time required for a turn to change the heading in the amount of psi radian is equal to the T is equal to 2 pi r by V psi by 2 pi. So this 2 pi is cancelled. Here we have r into psi by V. This equation implies that to reduce the time of a turn, one must increase the airspeed and decrease the turn radius. So in this case, to have the maximum, to reduce the time, if you want to reduce this time t, this should be high or maximum, and this radius should be minimum. Okay, so this equation implies that to reduce the time of a turn, one must increase the airspeed and decrease the turn radius. We know that r is equal to, we have already, in the previous my lecture we have derived that this turn radius r is equal to v square by g tan phi, and we know that time is equal to here r psi by v. So here v into this we cancel. So V into psi by G into tan phi. So here we can see this equation implies that to reduce the time of a turn, one must increase the bank angle. So if you want to reduce this, you have to increase this tan phi. So phi should be increased, then the time will be reduced. Now I will discuss about turn rate omega, or the angular velocity psi dot. So the turn rate is the amount of heading angle psi that is traveled in a given time. So this omega is equal to turn rate. It is the psi dot d psi by dt. We know the turn velocity v is equal to r into omega. The turn radius r is defined as r is equal to v square by g tan phi. So putting this r value in this v here, we can get v is equal to v square by g under root n square into omega. Or we can see that in this case that omega is equal to g under root, opposite to this, g under root n square by v. This is the angular rate. Or omega is equal to g under root n square minus 1 by v is equal to tan phi. So g into tan phi by v. Turn rate depends only on the airspeed, velocity and the bank angle. So this turn rate is depend upon the airspeed v, it is called v, and the phi. So the maximum turn rate can be mathematically achieved when 1. The highest possible bank angle. So phi should be maximum. So phi maximum, then we should lowest possible airspeed, v minimum. So v stall is the lowest possible. So phi should be maximum, bank angle should be maximum, and speed should be minimum. That time you can achieve the maximum turn rate omega. So here omega maximum, we can get that g tan phi maximum divided by v minimum. So this is the final equation which we have got, that for maximum turn rate, omega maximum is equal to g into tan phi maximum. Phi should be maximum and velocity should be minimum. This we have to take care to get the omega maximum. Now we will see the problem. Consider a very light aircraft with a mass of 750 kg and airspeed of 100 knot. If the maximum permissible load factor is 3.8, what is the equivalent maximum bank angle of this load factor? So if you see here, weight is given, airspeed v is also given, n is also given. So what is the equivalent maximum bank angle? So I think we know that n is equal to 1 by cos phi, or cos phi is equal to 1 by n, 1 by 3.8. So we can find out this very easily. Determine the corresponding turn radius r for a coordinated turn with such a angle. So we have to find out this phi, and then we have to find out this r, and we know that this r is equal to here v square by g tan phi, v square by g tan phi. So we can use this equation. If the aircraft turning coordinately with the radius r and the bank angle 30 degree, calculate the airspeed and the load factor. So here r is given here, r is given 300 meter and phi is 30 degree. Find the v and n. So it is n is equal to 1 by cos phi, 1 by cos 30. So this you will get it. So just we will solve it. Bank angle, we know that n is equal to 1 by cos phi, and it is given as a 3.8. So phi, you will get 75 degree. Turn radius V square by G under root n square minus 1. V square, it is 100 knots into 0.5144. 1 knots is equal to 0.5144 meter per second. This you have to use it. So V square by 9.8, 3.8 square minus 1. So you will get 72 meter. The radius of turn R is equal to 72 meter. Now load factor N is equal to 1 by cos phi. In other case, it is given 30 degree. So you will get N is equal to 1.154, and air speed we have to find out. R is equal to V square by G N square minus 1. So V is equal to under root RG N square minus 1. R is 1, G is 9.8, R is equal to 300, all the values. So this velocity we can get as a 41.2 meter per second. So this is the solution for this problem. Now we will go for the next problem. Determine the stall speed of a utility aircraft with a mass of 4,500 kg, a wing area of 19.5 meter square, and the maximum lift coefficient of 2.5. Perform this analysis at the sea level for the following two flight conditions: cruising flight and the turning flight with a bank angle of 30 degrees. So here the mass is given 4,500 kg. Area S is 19.5 meter square. CL maximum is equal to 2.5. So for the cruising flight, we have to determine stall speed Vs. I think we know that under root 2W rho V square into CL maximum, W by S. So M is given, S is given, CL maximum is given, rho is given. So this directly this you can find out. And for the, now you have to add the 30 degrees. So divided by 10, 5, we can get the turning flight with 30 degree. So now we will see. So at sea level, the air density is 1.225 kg per meter cube. If it is not given, we have to remember this because it is a constant value and everyone should know. You know that the cruising flight is equal to Vs is equal to 2W by rho SCL maximum. W is equal to mg. So 2 into m is given 4,500 plus g is 9.81 divided by 1.225 into 19.5 into CL maximum whole under root. We will get 74.7 knot. This is the minimum velocity of the aircraft. Okay. So now turning flight with a 30 degree bank angle. So we know that Vs is equal to 2 mg by rho CL maximum cos phi. So 2 into this thing only, we have to add this cos 30, and now we will get Vs is equal to 80 knots. So very interesting that for turning flight, stall speed is higher than cruise flight by under root 1 by cos phi. This you have to multiply, then you will get. So it is higher than the normal flight. So it is very interesting to understand that effect of the turning. If you are turning the aircraft like this, you cannot go less than this Vs, and this Vs of the turning flight is higher than the same aircraft when it is cruising, and it is depend upon the angle of the turn, angle of the bank. If it is the high bank, your velocity will be higher and higher. So we cannot go like 90 degree. We have to go some angle for the turning. These all things we have to decide before attempting the design. We all are the engineer, and we should not just start. First we understand that our aircraft will turn and how much maximum turn it is possible by this aircraft. This you can calculate by using this type of equations. Now I am going for the next problem, that is equation number. The aircraft introduced in problem 2 is cruising at speed level with a speed of 250 knots. Assuming that the lift curve slope CL alpha of the aircraft is 0.1 per degree and alpha naught is equal to 0. Determine the aircraft angle of attack for this flight condition. If the pilot decides to turn with a 45 degree of the bank angle while maintaining the same airspeed, what is the aircraft angle of attack? So very interesting and very simple. It is not a very big issue in that. So here CL alpha is given. So speed is given, and the problem of the previous one, which is weight and everything, is given. So aircraft average aircraft angle of attack we have to find out alpha. So we know that CL is equal to 2W by rho V square S. 2 into 4500, 9.8, 1.22, V is equal to 250 into 0.5144 square into 19.5. So we got the CL is equal to 0.22. We know that CL is equal to CL alpha into alpha. So alpha is equal to CL by CL alpha. CL we have got 0.22 and alpha is given 0.1 CL alpha. So 2.2 degree. So angle of attack is 2.2 degree. So this is the answer for the problem A. So now new aircraft angle of attack. So if you see here, if we turn, what will be the angle of attack? It is more or less than this. That is the important. So we are turning 45 degree. Aircraft is moving like this and turning 45 degree. How much angle of attack your aircraft will experience? That is it is increasing or the decreasing. So now CL is equal to 2W rho V square S cos phi. So 2 into 4500. So 2 into 4500 into 9.81 G divided by rho 1.225 into 250 knots into 0.5144 V square into rho V square S is equal to 19.5 and cos of 45. So this you will get the CL value 0.31 and here you got the 0.22. So this 0.31 divided by 0.1, 3.1. So you got this angle of attack 2.2 and 3.1. So 3.1 minus 2.2 divided by 3.1. So you will get here 0.9 divided by 3.1 or 9 by 31. So nearly it is 3% increase. So as you increase the angle of attack, your 3% or 30%, I think. 30% increase of angle of attack is experienced only by the bending. Note, aircraft requires a greater angle of attack in a level turn compared to with a cruise flight. So more than, so just I will see. Okay, nearly 30% increase of angle of attack is experienced by increasing 45 degree of bank angle. So in the next lecture, I will be discussing this topic, level turn performance, important parameter of load, variation of the maximum load factor versus airspeed in a level turn, corner velocity, maximum of the maximum load factor, airspeed for maximum of the maximum load factor. These topics I will be discussing in my next lecture. The references are Anderson JD, Aircraft Performance and Design, International Edition, McGraw Hill's first edition, 1999. SL by ME, Aircraft Performance, Theory and Practice, AIA Education Series, AIA 2. Any questions, you are welcome to ask. My email ID is ydwivedi, DWIVEDI, @gmail.com. You please do like and subscribe my channel. Do the comments. If any mistake you find, please let me know. I will try to correct it. Please do like and subscribe. Thank you very much for the joining. Be tuned for my next lecture. Till then, goodbye and see you.
Like, share and subscribe. Hit the bell icon for more updates.